Defects in solids. Defects are mainly two types. They are point defects and line defects. Point defects are due to deviation around a point or an atom in a crystal. Line defects are due to deviation in the entire rows of lattice points. 1. Point defects. Point defects: impurity, non-stoichiometric, and stoichiometric defects. A. Impurity defect. This defect is due to the impurity in the crystal. For example, in molten NaCl, if SrCl2 is present, then some of the Na plus ions are occupied by Sr plus 2. Each Sr plus 2 replaces two Na plus ions. One of the sites is occupied and the other remains vacant. The vacancies are equal to number of Sr plus 2 ions. Another example is solid solution of Cl2 chlorine and AgCl silver chloride. B. Non-stoichiometric defect. These are two types: metal excess defect and metal deficiency defect. Metal excess defect due to an ionic vacancy. It is due to the absence of an ion from lattice site, leaving a hole which is occupied by electron to maintain electrical neutrality. The anionic sites occupied by unpaired electrons are called F centers. German word Farbcenter means color center. More number of F centers, more will be the intensity of color. NaCl, sodium chloride, is an yellow. LiCl, lithium chloride, is pink. Metal excess defect due to presence of extra cation at interstitial sites. Example, ZnO, zinc oxide. This is due to the movement of metal ions to interstitial sites and the electrons to neighboring interstitial sites. Example, ZnO, zinc oxide, is white when cold and yellow when hot because it loses oxygen and Zn plus 2 ions occupy the interstitial sites. Metal deficiency defect. Example, FeO, ferrous oxide. This is due to absence of a metal ion from its lattice site and charge is balanced by ion having higher positive charge. Generally, transition elements exhibit this defect. FeO, ferrous oxide, is mostly found with a composition of Fe 0.960. It may range from Fe 0.930 to Fe 0.960.